Bismillahirrahmanirrahim. Assalamu alaikum. Today we have our seventh lecture, which is about confusion matrix. So basically, confusion matrix is actually confusing, but we will try to explain it in the very easiest manner. So let us start. Let me open my visual demonstration in the paint diagram, and then we can start. Today, the topic of our discussion is confusion matrix. Let us see this graph. Here is a graph, and you can see there is a line which is of blue color, and there are points. The points above the line are of blue color, means the data have same characteristics or the same features. बेसिकली वी आर क्लासिफाइंग द डाटा, हम डाटा को तोड़ रहे हैं. हमारे पास यहाँ पर लाइन के ऊपर जो डाटा मौजूद है ये एक ही फीचर्स का है, एक ही क्लासिफिकेशन का है. फर्स्ट कर लेते हैं ये डाटा पॉइंट्स लाइन से जो ऊपर है, इससे हमें पता चल रहा है कि ये डॉग है, डॉग के डाटा पॉइंट्स हैं, डॉग के फीचर्स हैं. और लाइन से नीचे जो हमारे पास पॉइंट्स मिल रहे हैं, यानी ये लाइन दोनों डाटा को सेपरेट कर रही है, ये बता रहा है कि ये कैट है. सो बेसिकली वी आर क्लासिफाइंग द डाटा with the help of a line, and the points above the line are the features of the breed of dog, and the line below and the data points below the line are the features of the cat. तो बेसिकली कंफ्यूजन मैट्रिक्स क्या है? कंफ्यूजन मैट्रिक्स ये है कि यू हैव टू मेक अ मॉडल. What is the model? Suppose the model is a box, and you are going to input the data, and it will classify whether the picture you input is a cat or a dog. So basically the model is a classifier. So what is the confusion matrix? The confusion matrix is basically telling us the accuracy of your classification model, how much your classifier is good, how much your classifier is best, and how much your classifier is perfect. So let us move towards the matrix. The x-axis of the confusion matrix, which is this, the above axis, you can see it. The x-axis of the confusion matrix is the actual data. You know actually the picture you are inputting is the cat or a dog. Or the y-axis in the confusion matrix is the prediction of our model. So let us see it. We are drawing the y-axis, and this y-axis is what? This y-axis is the predicted output of your model. So we have written predict here, and we have written actual here. So in the actual, which is the x-axis, there are two things. The one is positive, the second column is negative, and on the y-axis, which is the predicted column, the one is positive and the second is negative. So let us move inside the confusion matrix, and I am sure that if you get the proper idea, you will not get confused about the concept. You will be 100% clear about your concept and about your understanding. So first of all, the first thing on the x-axis is this positive sign, means in actual the dog is present, the picture you are inputting is a dog, and if you intersect these actual column with the predicted column, there is a positive and there is a positive also. So true positive makes true positive, means the picture you are inputting is the dog and the model has predicted it as a dog. So the first row in the first column intersect at a point which is this, it is true positive. Now I am moving towards this. The model is telling you the negative results, means it is not a dog, and the classifier is also telling you that it is not a dog. True not means true negative. True positive TP or true negative TM are the correct results of a classifier, means in true positive the model predicted that it is a dog and in actual it is a dog. It is true positive. Two positives makes true positive. And on the other hand, the model predicted it is not a dog and in actual it is not a dog. Two negatives makes the true negative, which is TN. Okay, so that's the understanding of true positive and true negative. Now there are two boxes remaining. Two boxes are still empty. These two boxes are always wrong predictions. Suppose that we have all the points lying, brown points lying under this blue line, and by falsely model take two brown points with the blue points. So this classification is wrong, and this prediction and this work done by the model is absolutely wrong. Suppose there are blue points above the line and we start making blue points below the line as well. So this classification is wrong. So the confusion matrix always tells us that how many classifications are correct or how much your model is precise and how much your model is accurate. So the confusion matrix holds a very important place in determining the classification and accuracy of our model. So still the two boxes are remaining. What are these two boxes? I have told you true negative and true positive. The boxes remaining are false positive and false negative. So I am writing here FP, false positive. What this false positive means? Suppose in actual there is not a dog, the actual there is negative, but the model says that it is a dog. So the model is making the wrong predictions. It is known as false positive. We can see it here that the model is putting the brown points with the blue points. It is wrong. And the other thing which is remaining is the false negative. Suppose in actual there is a dog, but the model says that there is no dog, so it is false negative, and it is also the wrong predictions made by the model. So in confusion matrix we are determining the precision and the accuracy of a model using these techniques. I hope you have the better and the proper understanding of the true positive, true negative, false positive and false negative. False positive is also known as type 1 error. We can also call it as type 1 error. And the false negative is also known as type 2 error. So these are the name of the errors, and you always know, you also know these are wrong predictions. So let us move towards the visual diagram. I have tried to explain you better with the help of visual demonstration. So let us move towards the presentation and you will get the more proper idea about this. So let me start the slideshow and you can see the thing I have told you in visual demonstration is in front of you. You can see the true negatives, the true positives, the false positives and the false negative. Now let us move towards the video so you can get the more clear idea about the confusion matrix and its KPI. What is KPI? KPI is the key performance indicator. So leave it for now and move towards the video.
Used for classification purposes, we're going to rely on what we call a confusion matrix, which is a matrix used to perform basically to assess the performance of a classifier. What we do here is we have simply our model predictions and we have what we call it the true class. So predictions are either positive or negative, one of two classes. The true class is either positive or negative. Simply put, that's what the model is predicting. That's what the model is telling me. Okay, like for example, a patient is, let's say, has cancer, for example, or not. So if the patient has cancer, I'm going to be here. If the patient does not have cancer, we're going to be negative. Okay, and here we're going to put the true class, which is either positive or negative as well. What happened is, if my model predictions matches the true class, that's good. That's what we call it true positives. Then everything is great and the model is perfect. And if, for example, the model says that the patient doesn't have cancer and the patient in fact did not have cancer as well, then we're going to call it true negative. So we're going to put the total number of correctly classified samples in here. Okay? And now everything looks good. True positives and true negatives are perfect. However, models have problems. Models in general, sometimes they mess up. So let's take a look at some of the mess ups. Let's assume that the model predicted that the patient have cancer, okay? However, in fact, the patient was actually negative, which means the patient was actually safe to start with. He didn't have any cancer, okay? So that's what we call it false positives. The model messed up and he claimed that the patient has a disease, but in fact, the patient was fine. And this, what we call it type 1 error. And now to the problem, now to the issue, which is what we call it false negatives. And that's why I highlighted it here into red, because that's a major problem in models, when it comes to models. That's when the model predicted that the patient doesn't have cancer. So, we collected data of the patient and we trained the model, and the model said, you know what, this patient is fine. However, in reality, in fact, the true class was actually positive. And that's a huge issue because now the patient is in danger. He is not receiving any medication to stop the cancer or to stop the progression of cancer. So that's why we call this type 1 error and we call this type 2 error. And it's a huge issue, type 2 error. And actually type 2 error as well is huge, let's say in any other application. And let's say self-driving cars, for example. False negatives is a huge issue. Why? Because, for example, here the true class might be positive, which means in fact, for example, there is a pedestrian. However, my network or my model said, you know what, there is no pedestrian. Okay, so that's a huge issue too. Again, you can apply the confusion matrix or these concepts in pretty much any classification application. Alright, so a confusion matrix is used to describe the performance of a classification model, and we have true positives, true negatives, false positives, and false negatives. True positives are cases when the classifier predicted true, which means that we have a disease, and the correct class was actually true. In fact, the patient has a disease as well. True negatives is cases when the model predicted that it is false, which has no disease, and the correct class was actually false as well, which means that the patient did not have a disease as well. So true positives and true negatives, they are good. Okay, that's when the model actually get it right. Now to the problems. We have what we call it false positives and false negatives. False positives are what we call it type 1 error. That's when the classifier predicted true, but the correct class was in fact false. false, which means that the patient did not have a disease to start with. Okay? Again, it's an error, it's a mistake, but the patient is fine. That's what we care about, right? And that's why we call it type 1 error. For false negatives, and that's type 2 error, that's when the classifier predicted false, which means the patient do not have a disease, but they actually do have a disease, and that's an issue. That's a big problem. All right. So let's see how can we assess the performance of the model. So there's a lot of KPIs, or key performance indicator, when it comes to classification problems. And when we apply the logistic regression classifier, we are going to assess the performance of the model based on these. First, we have our classification accuracy, which is true positives plus true negatives divided by the overall number of samples. Simply put, we'll go back to the matrix, sum up these two. So we're going to sum up how many samples have been correctly classified as positive and as negative, so sum them up, divided by the overall number of samples, divided by true positives plus false negatives plus true negatives as well. Okay? And then we have the error rate, or misclassification rate, which is false positives plus false negatives divided by true positive plus true negative plus false positive plus false negative. Again, we're going to count how many times we messed up. Okay, and then we have two important definitions, and we call them precision and recall. Precision is simply the true positives divided by the total true predictions, which means it's simply the true positives divided by true positives plus false positives. That's when model predicted true class. How often was it right? Okay, so simply when the model said that I am positive here, how many times he was right? How much of the model was right? Which is simply true positives plus true positives plus false positives. And that's what we call it precision. The next important definition is what we call recall, which is true positive divided by the actual true, which is true positive divided by true positive plus false negatives. And that's when the class was actually true, when the class was actually positive. How often did the classifier got it right? Okay, that's the overall idea. So we basically go here, divide true positives divided by true positives plus false negatives. Okay, all right, okay, and let's take a look at actually practical example. I know it might sound a little bit confusing. That's why I tried here to add an example for you guys to compare the precision and recall. Okay, let's assume that I have a patient, okay, and I have all these numbers in here. So let's assume that I have 100 patients, okay, and in reality, okay, we have 91 patients that do not have cancer. So I have 91 patients who are totally fine, everything is good, okay, and I have 9 patients that do have cancer, okay, and the perfect model will be able to correctly detect these 9 patients and isolate them. We're going to say, okay, these 9 patients have cancer and we need to treat them to basically clear the cancer and maybe like give them a chemotherapy or whatever medication to actually fix it up. Okay, all right. So let's assume that we have a model, and that model gave me these results. The model true positives were equal 1, true negatives were equal to 90, false positives were equal to 1, and false negatives were equals to 8. So if you sum them up, you will come up with 100 samples, right? Okay. So first, let's calculate the classification accuracy. So the classification accuracy, as I mentioned, we are going to count how many samples I was able to correctly classify. So I sum up 90 plus 1, so true positives plus true negatives, divided by 100, which is all samples, summation of everything. We'll come up with 91%. So if you take a look at it, you would say, wow, that's amazing. You know, that means, you know, like the model is 91% accurate, everything looks good. The model has able to correctly classify 91 samples out of 100. However, if you dig a little bit deeper, this model is actually garbage. You cannot use this model in practice. Why? And that's where precision and recall comes into play, and they can expose the limitation and shortcomings of the models. So precision is true positive divided by total true predictions. So is simply 1, which is true positive, divided by true positive plus false positive. So I'm going to divide 1 divided by 1 plus 1, which means it's half, will equal 50%. Which means that basically the model is 50% correct, which is horrible. These results are really terrible. Which means that, again, when I say precision, that means when the model said that it's positive, when the model said that the class was positive here in the row, how many times it was actually right? You will find that the model said that there were only 2 positive cases, and basically the chances of like it's the precision was only 50%. So it only got it 50% right, which is terrible. And now to the another important element as well, or important metric, which we call a recall. Recall is simply our true positive, okay, divided by the actual true samples, which here we have true positive divided by true positive plus false negatives, which is 1 divided by 9, which is 1 plus 8. So here we have 11% recall, which does that mean that this model is actually, again, the performance is really bad. And as you guys can see here, recall simply try to obtain when basically the how many samples, how many of the 9 samples that we have, how many of these cancer patients I have been able to correctly classify. So here I have been able to correctly classify only 1 sample out of 9 samples, which is, again, we cannot deploy this model in practice. Because this model, yes, on the outside it looks amazing, 91%. However, the recall is 11%. It can only detect 11% of the samples. Okay?
तो ये आपने जो है एक एग्जाम्पल देखी और यू हैव ऑल्सो सॉल्व द प्रैक्टिस एग्जाम्पल of the classification of the disease of the cancer patients. So this is another example case that we are going to explain it more deeply. Before going towards this or true or false, you have already seen the visual demonstration of the confusion matrix. But before going forward, I want you to do a Python example. Then we can move towards this homework question, and you all will solve this homework question by yourself. So let us move towards the practice and we will discuss it in a more deeper details in order to make your understanding very clear. So let us start the Jupyter notebook, and then I will start writing some ordinary data, some random data, and then we can do the confusion matrix in practical, so you can understand what is happening, so you can get the clear concept about this confusion matrix. So I am here import number as np. After importing numpy, what I am doing, I am making an empty matrix. What is an empty matrix? Let me write it. I am writing a variable y prediction is equals to np dot zeros. So first of all, I have to explain what this np dot zeros will do. I am making a matrix of 10,000 values. In actual, the np dot zeros, if used, what it will do, it will make an empty matrix with 1,000 values. And what are the values inside this matrix? The values should be 0 point, 0 point, on row 1, column 1, 0 point, and the second one. So there are 1,000 values, all are 0 in very simple terms. So let me write another variable, and in this variable I am writing is equals to np dot zeros, and what it will do, you can see it, I am again writing 10,000. So it will generate a matrix of 10,000 values. In order to get yourself clear, I am writing this again or printing this matrix, so you will get the idea what is happening inside it, and you can see by visually by yourself what does this y predict or y test variable contain? So I am printing this matrix by using the print command and running this so you can get the clear idea. So I am running it. You can see it has printed 0 0.0 point and dot 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 dot. It consists of a simple matrix with 10,000 values and all the values are 0. I hope that you have got the clear idea about it. Now I am making another variable. What is that variable? I am writing indices 1 is to np dot random dot randint. You have already studied the randint function, and what I am doing in this randint function, I am making another variable named as indices 1, and the range of this variable is 0 comma 10,000, means it will go from 0 to 10,000 and it will automatically take 300 values between the range 0 to 10,000. I am copying this line and making another variable named as indices 2. Let me write it, and now it will take 400 values from 0 to 10,000. Now I am making another variable, and this variable is indices 3, and indices 3 will take 400 value 500 100 increment 500 values from 0 to 10,000. And now I am doing the very important thing. As you already know that indices 1 consists of 300 values from 0 to 10,000. The variable indices 2 consists of 400 values. The variable indices 3 consists of 500 values. So what I am going to do now, I am taking my old variable which consists of 10,000 values, which is the y prediction variable, and I am making the indices 1 as 1. What it means, let me show you. I have written y prediction, and inside the square bracket I have written indices 1 is equals to 1. What it will do, it will automatically go inside the y prediction variable and convert the 0 values to 1. Let us see some of the 0 values to 1. Let us see the output so you can get what is happening inside it. Let me run it. So it is showing you the array of y prediction, but forward moving towards inside these dots, you will get to know that most of the values inside these indices 1 is now 1 instead of 0. So I am repeating the same thing for other variables as well. Y test indices 2 is equals to 1, and again y prediction indices 3 is equals to 1. Let me explain it again, that what is happening inside this y prediction and indices variable when we are using y prediction or y test. It 1, you can see I have printed y test, and you can see there is a 1 value. Randomly it is providing the values from 0 to 1. As you already know that y prediction and y test consist of 1000 values, all are 0. On the basis of indices, we have assigned 1 to some of the places. Let us move forward, and I am calculating the sum of all the values inside y test. So y test consists of 1 sometimes and or sometimes 0. So let me calculate the sum of y test, and here is the sum. It is 857. Now I am calculating the sum of y prediction. So I am writing PRED prediction, and it will show you the sum. So it is 770. So basically I want to show you that inside of these 10,000 values of 0, I have converted them into 1. Some of them are converted into 1 randomly by using these 4 lines. Let me move forward, and now we have y prediction and y test at sum of 857 in y test array, and sum is 770 in y prediction. Now let me move towards and find the accuracy of this data. What I am doing, I am from sklearn. It is a library of Python dot matrix, and I am importing I am importing accuracy score as it is a matrix, and I want to calculate the accuracy just as I have explained you in the video of confusion matrix. So I am printing the accuracy. So let us see what should be the result. I have written accuracy score, and after that I have comma, and in the accuracy score I am writing again this variable accuracy, built-in command of Python accuracy score. And now I am going to calculate the accuracy of both the variable named as y test and y prediction. So I am writing here y test comma y prediction. Now I am running it, and let us see what is the accuracy score of our data. So I have run it and it is running. Let us wait and see the output. So it is running, and we have imported accuracy score from the Python library named as sklearn. So let us see towards the screen and manage to know what is our actual data. So the accuracy score is in front of you. It is 0.9375. I also want to know about the confusion from this library, so I am using this again from sklearn.matrix, and I am importing fusion matrix. So you don't have to put the formulas, the long formulas you have seen in the video. You can do everything directly, so it will be a lot of easiness for you to perform these tasks. So I have imported the library of confusion matrix. Now I want to know the confusion matrix of my arrays of my data. So I am writing here confusion matrix, simple Python command, and now I will write y test, the two variable which consist of a lot of zeros, and on some places there are one. So I want to know the confusion matrix of my raw generated data. Now I am running this. So it is saying something. Let us see. It is saying there is no variable y predict. So we have written PRED as the spelling of predict. I am running it again. Now you can see the confusion matrix in front of us. We have seen the confusion matrix. In the same way, we can see the classification data as well. I am writing from sklearn.matrix and the classification report. So from sklearn.matrix you have found the accuracy score, you have found the confusion matrix. So I am telling third time by using this library how to find the classification report, and the classification report consists of precision and recall as well, which we have discussed in the video. I am not explaining it manually because we have now Python programming language, and everything can be done easily with the help of this language. So it will be a very easy step in Python instead of doing these all the things manually. So I have written print classification report, and I am providing it the same two variable y test and comma y prediction. So I am running it, and let us see. You can see that it has made the classification report for your confusion matrix. The recall is 58 or the 97, and the precision is 96 or the 95. You can see the average or the total at the bottom. We are not interested in F1 score or the support. We are telling it that you can see the precision and recall. It is the random practical that you should have to perform, that how to calculate these things for any data in Python programming. I hope that you are clear in your point and you have got the proper idea that what we are doing and what we are performing, and in the future you will perform these things for your own data as well, for another, for the data which is another than the random data. Let us move towards your slide, and then we can assign you the homework. So this is the confusion matrix, another example, and this is a classifier which made around 165 predictions, and it is predicted that 165 patients, and it is in reality 105 patients have the disease and 60 patients do not have the disease, and what the classifier predicted is in front of you and you can easily see it. I have already told you that what it is the true negative, and what is it, it is the true positive. These are the correct classifications, and these two columns are always wrong, are also known as type 1 and type 2 error. So I am leaving it on you that you have to examine this example and produce the result with the help of Python programming as well. That's all for today. Thank you so much. I hope you have got the clear idea about the confusion matrix. Thank you.